All right, let's get into it. Today we're going to put on our detective hats because we're diving into the world of data. And trust me, it can be just as messy and full of hidden clues as any crime scene. We're talking about the essential, sometimes gritty work of data cleaning. So let me just ask you something right off the bat. When you picture a data scientist, you probably think of them building these incredible, complex models or creating amazing charts, right? But what do you think they spend most of their time actually doing? The answer might actually surprise you. It's not the cool analysis part. It's not the big aha moment. Nope. For most people in the field, the biggest time sink is the cleanup. It's all the prep work that has to happen before the fun stuff can even begin. So what is data cleaning really? Well, think of it as the first and most critical step in any data investigation. It's all about hunting down and fixing all the little mistakes, the weird inconsistencies, and the gaps in your information to make sure your data is accurate, consistent, and actually usable. And let me tell you, the stakes here are incredibly high. I mean, you wouldn't want a detective working with tainted evidence, would you? Of course not. It's the same exact thing with data. It's a simple rule we all know. Garbage in, garbage out. If you start with messy data, you're just going to end up with flawed conclusions and models that are totally unreliable. Every good detective knows you gotta identify your suspects first. And in the world of data, our culprits are the common types of errors that always seem to sneak their way into our datasets. So let's go ahead and meet the usual suspects. Okay, here's our lineup. First, you've got missing values. You know, the clues that just weren't there to begin with. Then you have noisy data. Think of these as false leads or just plain typos. Next are duplicate records, where it's like the same witness giving their testimony twice. And finally, inconsistent formats, which is like everyone telling the same story but in a completely different language. Our job is to track down every single one of these. Okay, now for the fun part. We're going to open the case files on each of these suspects and walk through exactly how a data detective cleans up the scene, turning a chaotic mess into a story that actually makes sense. Let's jump into our first case. So here we have the case of the missing clues. Just look at this table. See those null spots? For person number 2, we have no age. For number 4, the income is just gone. These are like giant holes in our evidence. If we try to calculate the average age or income right now, our answer would be totally off. So how do we fix it? Well, we can use a pretty clever technique called mean imputation. It sounds a little technical, but the idea is actually super simple. To fill in a missing number, you just calculate the average or the mean of all the other numbers in that same column. Then you just plug it in. It's like making a really educated guess. And boom, just like that, case closed. The average of the ages we did have was 28, so that fills one gap. The average of the incomes was 4167, and that fills the other. The holes are patched up, and our data is whole again. On to the next mystery. All right, next up, the case of the unreliable witness. So imagine this is a log of daily temperatures. We've got 25 degrees, 26, 27, and then, whoa, 300 degrees? Unless we're logging temperatures on the surface of the sun, that number is obviously wrong. That's a perfect example of what we call noisy data. So how do we deal with this kind of unreliable witness? We use a technique called smoothing. Essentially, we look at the data points immediately before and after our crazy outlier, that 300-degree day, and we make an assumption that the real temperature was probably pretty close to its neighbors. So we can just average them out to find a much more realistic value. And check it out, the fix works beautifully. We took that wild 300 and replaced it with 26.5, which is just the average of the temperatures from day 2 and 3. The signal is restored, the noise is gone, and our log makes sense again. Our third case file is the case of the double identity. Now, look closely at this one. See it? Customer 101, John from Doha, is listed twice. Exactly the same entry. This is a classic duplicate record. Now, if we were trying to count our customers, this would throw our numbers off. It seriously skews your results. Thankfully, this is one of the more straightforward cases to solve. The detective's job is simple. You find the duplicates and you get rid of them. You just make sure every person or item is only counted one time. It's a simple step, but absolutely critical. And there we go. Problem solved. The duplicate is gone, and now our customer list is clean and accurate. One record, one unique identity. That's what we want to see. Case closed. And now for our final investigation, the case of the conflicting timelines. This one is a huge headache in the real world. You can see here that all 3 of these entries are talking about the exact same day, March 12th, 2024. But to a computer, these look like 3 completely different, unrelated pieces of text. This makes it impossible to sort or analyze your data by date. And this slide really nails the problem, right? On the left, you've got total chaos, 3 different ways of saying the same thing. On the right, you have order and clarity. Our job is to turn that chaos on the left into the beautiful consistency you see on the right. And the solution is all about one word: standardization. All we have to do is pick one single format. The year, month, day format is a really common and useful one. And then we convert everything to match. It's like we're making sure everyone in our dataset is speaking the same language. And with that, the timeline is synchronized. All the dates are now in perfect harmony, totally uniform, and ready for whatever analysis we want to run. And just like that, all our cases are solved. So we've gone through the case files, we've identified all the suspects, and we've cleaned up the scene. But let's take a step back for a second and ask the big question. Why does all this detailed, nitty-gritty work really matter? It's time for the final verdict. The payoff for all this work is, frankly, massive. When you have clean data, it dramatically improves the accuracy and reliability of everything you do next. It leads to smarter decisions, better predictions, and algorithms that actually give you the right results. More than anything, it builds a foundation of trust. Without clean data, you're just guessing. With it, you're doing real analysis. So, I'll leave you with this final thought. Every dataset out there is trying to tell a story. But if you haven't done the detective work to clean it up first, you have to ask yourself, what crucial details, what hidden plot twists, what parts of the story are you missing completely? Thanks for joining me.